You're welcome to my YouTube channel, Mathematics Medicine. So in today's video, we are going to solve this beautiful question. So we have integral from 0 to a of e raised to the power of x raised to the power of dx, and this is equal to integral from a to 0 of x dx. So we have to solve for the value of a. Solution. Okay guys, so before we dive into the solution, please don't forget to subscribe to my channel, like my video, comment and share. All right, now let me quickly remind us the identity. This is called the product integral. So if you have integral from a to b of f of x, then raised to the power of dx. So this is equal to exponential, that is e raised to the power of integral from a to b, then of natural log of f of x dx. Now take note of this. So we are going to use this particular expression to solve this left hand side. Okay guys, so let's solve that left hand side. So solving our left hand side, we have integral from 0 to a of e raised to the power of x, then raised to the power of dx. Then this will be equal to, if you apply this particular identity, so that will be exponential, then integral from 0 to a, then of natural log of e raised to the power of x dx. Okay, then according to the natural log identity or property, so we have natural log of a raised to the power of b. This will be equal to b multiplied by natural log of a. Okay, so that is what's going to happen right here. So natural log of e raised to the power of x, this will be equal to x multiplied by natural log of e. And remember that natural log of e is going to give us 1. So this will be equal to x then multiplied by 1. Okay, so then we are going to have integral, e raised to the power of integral from 0 to a, then of x dx. And then if we integrate x, that will give us x raised to the power of 2, then over 2. The integral property. So we have integral x raised to the power of n dx. This will be equal to x raised to the power of n plus 1, then over n plus 1 plus c. Okay, so if we integrate x dx, that will be we are going to have exponential, that will be x raised to the power of 2, then over 2, then you apply the limit from 0 to a. Okay, so this will be e raised to the power of, so if you apply a, so you are going to have a raised to the power of 2, then over 2, then minus, if you apply 0, so that will surely give us 1. Okay, that will be e raised to the power of a squared over 2, then minus 1. Now that is the left hand side. Now let's solve for the right hand side. So the right hand side is integral a to 0 of x dx. So the right hand side integral a to 0 of x dx. So this will be equal to x raised to the power of 2 over 2. Then you apply the limit. So from a to 0. So when you apply 0, 0 over 2 will give us 0. So you have 0 minus. Then when you apply a, we have a raised to the power of 2 over 2. And this is the same thing as negative a squared over 2. Now, equating the two results. The first result is e raised to the power of a squared over 2 minus 1. So which is equal to the second result, which is negative a raised to the power of 2 then over 2. Now, how are we going to solve for the value of a? That's where the works comes in. This is somehow hard. So then how are we going to solve this problem? Okay, now this is what I'm going to do. I'm going to make a substitution. So making a substitution, we can set let a raised to the power of 2 over 2 be x. Okay, so if a raised to the power of 2 over 2 is equal to x, so we're going to have e raised to the power of x minus 1 equals negative x. Okay, so this is what we are going to do. We are going to divide both sides by e raised to the power of x over e raised to the power of x, then over e raised to the power of x. So we're going to have 1, then minus 1 over e raised to the power of x equals negative x multiplied by e raised to the power of negative x. Okay, and then 1 over e raised to the power of x here is also what? Negative x. So we are going to have then 1 minus e raised to the power of negative x equals negative x e raised to the power of negative x. Okay, then add e raised to the power of negative x to the both side. So you're going to have 1 is equal to negative x e raised to the power of negative x plus e raised to the power of negative x. So you can factor out e raised to the power of negative x. So we have 1 equals e raised to the power of negative x, then into negative x plus 1. Yeah, that is beautiful. We have e raised to the power of negative x into negative x plus 1. So this is what we are going to do. Now, why am I doing this? I'm going to apply the property or the identity called the Lambert W function. So that is the function I will be applying here. And then let me quickly write out the Lambert W function. Here's the definition. If you have y equals x multiplied by e raised to the power of x, then if you take the Lambert W function of both sides, so we have Lambert W function of y equals Lambert W function of x multiplied by e raised to the power of x. Okay, then Lambert W function of x multiplied by e raised to the power of x will be x. Okay, so that will be x, then equals Lambert W function of y. That is, I want this exponent to be something like this. Then what am I going to do? I have negative x here, I have negative x here. So the next I'm going to do now is to multiply both sides by e raised to the power of 1. Okay, so if I multiply both sides by e raised to the power of 1, so we are going to have something like this. Let me quickly clean this part. You are going to, uh, okay, now, if you multiply both sides by e raised to the power of 1, so we are going to have 1 multiplied by e raised to the power of 1 equals e raised to the power of negative x multiplied by e raised to the power of 1, then into negative x plus 1. Okay, so 1 times e raised to the power of 1 will give us e, which is equal to, so we apply the law of indices here, that will be e raised to the power of negative x plus 1, then multiply by negative x plus 1. What do you see? This exponent is the same thing like as this. Then you can now apply the Lambert W function. So applying the Lambert W function, we have the Lambert of e equals Lambert of e raised to the power of minus x plus 1, then multiply by negative x plus 1. Okay, so then we are going to have negative x plus 1 equals the Lambert function of e. Okay, then you can subtract 1 from both sides. So if we subtract 1 from both sides, we are going to have negative x equal Lambert W function of e, then minus 1. Then you can also multiply both sides by minus 1. So to do that, we have x is equal to 1, then minus the Lambert function of e. So that is the value of x. But guys, remember that a raised to the power of 2 over 2 is equal to x. Remember that. So, but we have to solve for the value of a, not x. So what do you think we are going to do now? So since we know that a raised to the power of 2 over 2 is equal to x, so that is a squared is equal to 2x. And then to know the value of a, you have to take the square root of both sides. That is, a will be equal to plus or minus square root of 2x. And we already know the value of x, which is 1 minus the Lambert W function of e. Okay, so I'm going to have e equals plus or minus, then the Lambert W function of 2, then into 1 minus the Lambert W function of e. So we have e equals plus or minus, then square root of 2 times 1 will give us 2, then minus 2 times Lambert W function of e. We have 2 Lambert W function of e. So you can use the Wolfram alpha to check the numerical value for the value of a. Alright guys, so that will be the end of today's class. So if you like this kind of video, please don't forget to subscribe to my channel, like my video, comment and share. Thanks guys, see you next time. Thank you for watching.